Okay, a composite function is combining two or more functions together. So I just want to give you a visual of how I think about functions. So we've got two functions here, g of x and f of x. So functions are like a machine. And that machine is called f of x. It's a function. It does a function. And what this function does is it takes your number x, times it by 2, and adds 3 to it. So for instance, if I put a 3 into this function, we times by 2 makes it 6. We add 3, it comes out as a 9. If we were then to apply this to a second function, which we're going to call f of x, this function takes the number and divides it by itself plus 5. So if I plug this into my equation, it's going to come out as 1 over 9 plus 5, so it's going to come out as 1 over 14. So this function does the first thing, and then this function does the second thing. So if I plug a 0 into this function, it's going to come out as 2 times 0, which is 0, plus 3. Comes out as a 3. Then I plug it into the second function, and it comes out as 1 over 8. If I plug a negative 2 into this function, it comes out as 2 times negative 2 is negative 4, plus 3 is negative 1. And then if I plug this into the next equation, it comes out as 1/4. If I plug an x in here, it comes out as f or g evaluated at x. And if I plug it into the second function, it comes out as f evaluated of g of x. So this is how it works when we're evaluating composite functions. You do your inside function first, and then you work your way towards the outside. So it's inside out. That's kind of how we have to think about it. So we have two functions. One's f of x and one's g of x. Same thing, kind of same idea with the box. So you want to evaluate it at the inside first. So we're going to do g of negative 1. So I'm going to go over here to g of negative 1. It comes out as a 2. So now I'm going to evaluate f at 2. So I'm going to come over here to f of x, and I'm going to go over to 2, and it comes out as a 3. So f of g of negative 1 is 3. Same thing here. I'm going to erase that. We're going to evaluate our inside first. So f of positive 3. So I'm going to go to f of positive 3, comes out as a 2. So now I'm going to evaluate g at 2. It comes out as a 5. So g of f of 3 is 5. Keep going here. We're going to evaluate g at 0. So go over to g at 0, it comes out as a 1. And now we're going to evaluate it at g at 1. So 1 comes out as a 2. So g of 0 is 2. And last one, we have f of 2. Oops, I want to change colors. There we go. F of 2, so I'm going to go over to f at 2. And it comes out as a 3, so now we're going to evaluate f at 3, which comes out at 2. So f of 2 is 2. So just remember to work inside to outside. So this can be done with an arrow diagram. It can be done with a table of values. It's literally exactly the same as what we just did. So we're going to do f evaluated at 2, which is 0. So now we're going to evaluate g at 0, which is 1. So g of f of 2 is 1. We can now do this with g of 2. So g of 2 is negative 1. So we're going to do g at negative 1 now, which is 2. So g of 2 is 2. So that's for the table of values. We can also use a graph. So this one is, I guess, the most complicated. So we're going to go to g of x evaluated at negative 2. So remember, we're looking for our y value. So our y value at negative 2 is at 8. So now we're going to evaluate f at 8. And this is function f. We go to 8. It's right there, and our answer is 3. So f of g of negative 2 is 3. Now we're going to go g of f of 3. So we're going to work on the inside. So we're going to do f of x first. So that's that function. So we're going to go over to 3, and our y value is 2. So now we're going to evaluate g at 2. And g at 2 is 0. So g of f of 3 is 0. Let's do another one. G evaluated at 2. So we already know g evaluated at 2 is 0. So now we're going to evaluate f at 0, which is 1. So f of g of 2 is 1. And last one, f of negative 1. So negative 1 is right here, and it's 0. So now we're going to evaluate g at 0, which is 4. So g of f of negative 1 is 4. So work inside out, find your point on your graph, and then use that to plug into your next graph. All right, thank you for coming to my TED Talk. Bye.